Let's do this problem right here. The question is asking determine all the values of p such that the matrix 1 1 1 2 p p 2 2 1 is not invertible. So first of all, we have to know in which case system is not invertible. The system is invertible when determinant is equal to 0. So if we have a determinant, for example, let's say this is a, so if determinant a is equal to 0, then in this case this is not invertible. So we have to find a condition that makes this determinant equal to 0, right? So let's see. So in this case we have to find the determinant of this one, but it's really hard if you there's a way to find plus minus, and that's too much stuff. But there's another way. You can bring this into upper triangular. Upper triangular basically means whatever the value below the diagonal should be equal to 0. So if you bring that pattern, what happens is when if you after you bring that pattern, if you multiply all the diagonal values, it's going to give you the determinant. So that way it's much easier than the other way. So therefore let's do this one. So to bring that one, let's see how we can do this. So 1 1 1 right here, I copy this matrix. uh, I go straight to this problem. So it's going to be to make this one equal to 0. So I had to make this all these two, because these three two are below the diagonal. So I had to make this equal to 0. Then I can find the determinant, right? So in this case, to make the first one equal to 0, I can multiply the first equation by 2 and add it with the second equation. So it's going to be minus r minus 2r1 plus r2, so which is going to give me 0 right here, and this is going to become p minus 2, this is going to become p minus 2. And the last one also I can do the same thing. I can multiply the first equation by minus 2 and add it with the third equation, so which is going to give me 0 0, and this is going to be minus 2 plus 1, which is going to be give me minus 1. Now we have created the upper triangular pattern. Now it's very easy to solve. If you now the only thing you have to do is you have to simply multiply the diagonal. Basically we have 1 p minus 2 and minus 1. So let's see what we get. So 1 times p minus 2 minus 1 should be equal to 0 in order to satisfy the condition that's not invertible. So if I equalize this one to 0, let's see what happens. This is going to be p minus 2 times minus 1 equal to 0. If you multiply this one by minus 1, this is going to become minus p, and this is going to become plus 2. Therefore 2 minus p is equal to 0. Therefore p should be equal to c2 in order to be invertible. So the answer for this question is determine the value of p should be, so the value of p should be equal to, should be p is equal to 2 uh, in order to in order in order for the system to be not invertible, in order for the system to be not invertible. So this is my final answer. So they are asking for the p-value that makes this system not invertible, and we have found the p-values. That's it. I hope you guys like this video. See you next time.